If you roll a fair six-sided die, there are 6 possible outcomes, and each of these outcomes is equally likely. A 6 is as likely to come up as a 3, and the same goes for the other 4 sides of the die. So what is the probability that a 1 will come up? Since there are 6 possible outcomes, the probability is 1/6. What is the probability that either a 1 or a 6 will come up? The 2 outcomes about which we are concerned, a 1 or a 6 coming up, are called favorable outcomes. Given that all outcomes are equally likely, we can compute the probability of a 1 or a 6 by dividing the number of favorable outcomes, 2 in this case, by the total number of possible outcomes, 6 in this case. So the probability of throwing either a 1 or a 6 is 1/3. Don't be misled by our use of the term favorable, by the way. You should understand it to mean favorable to the event in question happening. That event might not be favorable to your well-being. This formula applies to many games of chance. For example, what is the probability that a card drawn at random from a deck of playing cards will be an ace? Since the deck has 4 aces, there are 4 favorable outcomes. Since the deck has 52 cards, there are 52 possible outcomes. The probability is therefore 4/52, which equals 1/13. What about the probability that the card will be a club? Since there are 13 clubs, the probability is 13/52, or 1/4. Let's say you have a bag with 20 cherries, 14 sweet and 6 sour. If you pick a cherry at random, what is the probability that it will be sweet? There are 20 possible cherries that could be picked, so the number of possible outcomes is 20. Of these 20 possible outcomes, 14 are favorable, or sweet, so the probability that the cherry will be sweet is 14/20, or 7/10. There is one potential complication, however. It must be assumed that the probability of picking any of the cherries is the same as the probability of picking any other. This wouldn't be true if, let us imagine, the sweet cherries are smaller than the sour ones. The sour cherries would come to hand more readily when you sampled from the bag. Let us keep in mind, therefore, that when we assess probabilities in terms of the ratio of favorable to all potential cases, we rely heavily on the assumption of equal probability for all outcomes. Here is a more complex example. You throw 2 dice. What is the probability that the sum of the 2 dice will be 6? To solve this problem, list all the possible outcomes. There are 36 of them, since each die can come up one of 6 ways. The 36 possibilities are shown here. You can see that 5 of the 36 possibilities total 6. Therefore, the probability is 5/36. If you know the probability of an event occurring, it is easy to compute the probability that the event does not occur. If PA is the probability of event A, then 1 minus PA is the probability that the event does not occur. For the last example, the probability that the total is 6 is 5/36. Therefore, the probability that the total is not 6 is 1 minus 5/36, which equals 31/36.